A cube of aluminum has an edge length of 20 centimeter. Aluminum has a density 2.7 times that of water and has a specific heat of 0.217 times that of water. When the internal energy of the cube increases by 47,000 calorie, its temperature increases by what? By B, by 10. I don't know how they did that, but we'll get 10. She 10. An insulated container filled with water contains a thermometer and a pedal wheel. The pedal wheel can be rotated by an external source. The apparatus can be used to determine E, mechanical equivalent of heat. Take the mechanical equivalent of heat as 4 joules per calorie. A 10-gram bullet moving at 2000 meters per second plunges into a 1 kilogram of paraffin wax, a specific heat of 0.7. The wax is initially at 20 degrees Celsius. Assuming that all the bullet's energy hits the wax, the TF it's what? It's the 27,1. I don't know how they determine that. The energy given off as heat by 300 grams of an alloy as it cools through 50 degrees Celsius raises the temperature by 300 grams of water from 30 to 40 degrees. The specific heat of the alloy is what? Is the 0.20. The specific heat of lead is 0.030, and then 300 grams of lead shot at 100 degrees Celsius is mixed with 100 grams of water at 70 degrees or in an insulator container. The final temperature of the mixture is E, 72.5 degrees Celsius. Object A with heat capacity Ca and initially at temperature Ta is placed in a thermal conductor with object B with heat capacity Cb and initially at temperature Tb. The combination is thermally insulated if the heat capacity are independent of the temperature and no phase changes occur. The final temperature of both objects is B. The adding CATA plus CBTB divided by CA plus CB. The heat capacity of object B is twice that of object A. Initially A is at 300 K, B is at 450 K. They are placed in thermal contact and the combination is isolated. The TF of both objects is C 400 K. Heat transformation of a substance is the energy per unit mass absorbed as heat during a phase transformation. The heat fusion of water is calorie per gram. That means that 80 calories of energy are required to melt 1 grams of ice. Solid A with mass m is at a melting point Ta, is placed in thermal contact with solid B with heat capacity Cb and initially at temperature Tb. The combination is thermally isolated, so A has latent heat of fusion L, and when A is melted, has heat capacity Ca. If A completely melts, the final temperature of both A and B is A. So you add CATA plus CBTB minus ML and therefore divided by Ca plus Cb. 56. During the time that latent heat is involved in a change of state, the temperature just does not change. The formation of ice from water is accompanied by what? Absorption of heat, of energy as heat. How many calories are required to change 1 grams of 0 degrees Celsius ice to 100 degrees Celsius steam? The latent heat of fusion is 80 calories per gram and the latent heat of vaporization is 540 calorie per gram. The specific heat capacity of water is 1. So it's D 720. 10 grams of ice at negative 20 degrees is to be changed to a steam at 130 degrees Celsius. The specific heat of both ice and steam is 0.5 calorie per gram GC. The heat of fusion is 80 calorie per gram and the heat of capacity is 540 calorie per gram. The entire process requires 7,450 calorie. D. Steam at 1 atm and 100 degrees enters a radiator and leaves as water at 1 atm and 80 degrees. Take the heat of vaporization to be 540 calories per gram. Of the total energy given off as heat, what percent arises from the cooling of the water? E. 3.6. A certain humidifier operates by raising water to the boiling point and then evaporating it. Every minute, 30 grams of water at 20 degrees Celsius is added to replace 30 grams that are evaporated. The heat of fusion of water is 33 kilojoules per kg, and the heat of vaporization is 2256 kilojoules per kg, and the specific heat is 4190 joules per kg K. How many joules of energy per minute does this humidifier require? B. 8.8 times 10 to the power 4. A metal sample of mass M requires a power input P to just remain molten. When the heater is turned off, the metal solidifies in a time T. Specific latent heat of fusion of this metal is Pt divided by M. 50 grams of ice at 0 degrees Celsius is placed in a thermos bottle containing 100 grams of water at 6 degrees Celsius. How many grams of ice will melt? The heat of fusion of water is 333 kilojoules per kg and the specific heat is 4190 joules per kg K. Therefore, A, which is 7.5, is the correct answer. According to the first law of thermodynamics applied to a gas, the increase in the internal energy during any process, P, equals the heat input plus the work done on the gas, Q plus work. Oh, what's going on in this question? I feel like these things are all the same. Pressure versus volume graphs for certain gas undergoing. Well, they're not the same. Undergoing 5 different cyclic processes shown below. During which cycle does the gas do the greatest positive work? So the downward was... How can I claim this? Besides saying D is the correct answer. It's like you're looking at a plasma from a side and what else? And the arrows are going opposite each other. But the down arrow must go to the right, to the left. The up arrow must go to the right.